The last type of reaction, the common type of reaction that we'll talk about is double replacement. In double replacement, or sometimes double displacement, people will say, which means the same thing. Basically, you have two compounds and ions in them that are the same charge swap with the other one. So basically, the front of one compound combines with the back of the other, or the cation of one combines with the anion of the other. So you see here that B and D basically are swapping places. And so you have AB at first, and then you get AD, and you had CD at first, and then you end up with CB. Here is a actual example. You have lead nitrate and potassium chromate, and the lead and the potassium swap places, and you end up with lead chromate and potassium nitrate. All right, here's just an analogy of two girls. One has a jump rope, the other has a bouncy ball. They swap items and then they walk away. So now let's try practicing some of these. All right, so we're going to swap the fronts basically. So first identify the front, so Fe and then K on this one. So Fe is going to get the SCN, and K is going to get Cl. Now these are compounds, so we have to swap and drop. Fe's charge is 3, as you can see from that 3 that got dropped down there. SCN's polyatomic thiocyanate, 1 minus, so that gives us Fe parentheses SCN 3. Oh snap, did not mean to put a little dash across there. All right, K is 1 plus, Cl is 1 minus, so they just cancel. And then to balance the equation, put a 3 there, and then a 3 there. All right, the next example, again, we're going to do the same process. We're going to swap the fronts. So we have H and Al here. And so we're going to get H combining with the F. And then Al will get the SO4. Then you got to do swap and drop. So H is 1 plus, F is 1 minus, so they just cancel. And then over here, Al is 3 plus, SO4 is 2 minus, so that gives us Al2 parentheses SO4 3. Okay, and then you would need to balance. So let's see, we would need a 3 here, the SO4s. That gives us 6 H's, and then to get 6 F's and 2 Al's, we'd need that. And there's our balance. All right, let's look at the next example. Again, swapping the fronts. So you have 1 plus, 1 minus. Okay, so we get the H getting with the OH. So 1 plus, 1 minus, they cancel. And then K gets Br, 1 plus, 1 minus, so they cancel. And you're already balanced. All right, next example, we have PB and Na on the fronts, and then we have these little subscripts that are with polyatomics that will have to go with us. So PB is going to get the CO3, and Na is going to get the NO3. PB's charge was 2 from there, and CO3's is 2 minus, so they just cancel each other out. Na is 1 plus, NO3 is 1 minus, so again they cancel each other out. And then you would need to balance, so you'd put a 2 there and you'd be balanced. All right, Ag and Sn are going to swap places, so Ag with Cl and Sn with NO3. Ag's charge was 1 plus, Cl's 1 minus, so they cancel. Sn's was 2 from here, 2 plus. NO3 is 1 minus, so it's NO3 2. And then we would need to put, let's see, we'd need 2 of these and 2 of those. All right. And the last example of double replacement, again, identify the fronts. So H is going to get the HCO3, and then Na is going to get the C2H3O2. All right, 1 plus, 1 minus, so they cancel. Could combine this and write it like this. And then here, 1 plus, 1 minus, they cancel. And you can just leave it written like that. And you're already balanced.